Welcome, ladies and gentlemen, to Murph Codes, the new segment on my Twitch channel. This will be the segment where we're going to teach you, the viewers at home, how to learn Python easily. Like, there's countless tutorials on how to learn Python, but for the most part, they're aimed at people looking to get into programming. You know? They can be very boring. They can also be overburdened and stupidly complicated. This is not going to be that, I hope. So, let's get started. Alright. So, these are all the things I want to cover with this stream. Not this session, but we are going to try to get through a couple of these if we can. As fast as we can. Because I want it to be interesting for you. Alright, so in order to get started with learning Python, you should probably have Python installed on either your computer or your pocket device, whatever that is, tablet or cell phone. On screen, I'll walk you through how to install Python on a Windows desktop computer. If you're using Mac, the process will be quite similar, but you can probably check to see if you have Python on your computer already. I believe Macs may come with some version of Python already installed. It's entirely possible. If you're running Linux, it's almost a guarantee you've already got some version of Python, but I'll show you how to check that, and you'll be able to see if you want to update your Python so that you're following along with us, or make sure that you have the right version, because there's a couple versions of Python, and depending upon which one you're using, things can be different than what you see on my screen. If you're a phone user, you don't have access to a desktop or a laptop, don't worry. You're not excluded from this. What you're going to do is you're going to go to the Google Play Store, and on the Play Store you're going to search for, you'll search for this. QPython 3L. It's a nifty little app. Gives you a Python interpreter, a little text editor so you can write your code right inside of the app and test it there. And until we get to some of the later stuff, like graphic user interfaces, you'll be able to follow along just fine using this app. So don't get discouraged. If your phone is the only thing you have, you're not out of luck. You can still play along at home. I do believe the app is free. If it's no longer free, I believe I picked it up for free. It's not going to be super expensive. Most apps aren't. This one, at most, I imagine you may be paying $4.99, but probably not even that. So go download that. While you're downloading that on your phones, I'm going to walk you through how to install Python on your computer and get that properly set up. Now, I usually use Firefox for my browser, but today I'm going to be using Chrome because I imagine more people at home watching are probably going to be using Chrome. The place to properly download Python for your computer is just python.org. It's always best to just get it direct from the source, you know? And right up here near the top, handy little downloads tab. That drops down a menu. Select your operating system. I'm on Windows, so I'm going to select Windows. And here you'll see Python releases 4 and whatever your platform is. And it's got latest Python 3 release and latest Python 2 release. For now, ignore Python 2. We're going to ignore Python 2 and we're going to install Python 3. Now, like I said, there's a way to check if your computer already has Python on it. This works on everything. Open up your terminal or your command prompt, type in Python, hit enter. If it brings up the Microsoft Store for you Windows users, just go ahead and close that. If you're on Mac or Linux and you see if you see a different kind of prompt that just looks like that, that means you've started the interpreter, the Python interpreter. There'll be some jumble of text above that telling you what version you have. Go ahead and look at what version you have, and if it starts with a 2, if the numbers start with a 2, you'll still want to come to the website and download Python 3. If it starts with a 3, you're good. You're already there. You're already starting out ahead of the rest of us. Good for you. Since my computer does not seem to have Python 3 on it, I do have Python 2 installed somewhere, but I took it off of the system path so that we're not accidentally using Python 2. Well, that's new. I don't know what all this is about, but apparently it's a major release, so they've got some new interesting stuff there. Just go ahead and scroll down until you get to files. I mean, you can read all this stuff if you want, but, like right here, they're talking about Schwarzschild black holes. We're not here for that. Who cares? That's not us. So scroll down. You will see a couple of different options here. If you look for the recommended one, go for that. But be sure your computer is running 32-bit or 64-bit. If you don't know how to check that, on Windows. Oh, no, it's not that. How did I find that? Is that? There we go. Properties. And what you're looking for is how many bit operating system you have. Most of you, I imagine, are going to be working with a 64-bit computer if your computer is relatively new. If you're working with some old clunker, and it might be a 32-bit, you may also want to consider what version release you're working with, because as you can see here, some of these are only compatible with Windows up to a certain point. Like the latest Python 3.10 won't work on your Windows 7 systems anymore. So if you're still working with Windows 7, get the earlier version. Get the Python 7.12. It's a little older version. It's not going to affect your ability to participate. If you're still somehow using Windows XP, you might have to keep scrolling. When was the last version that was on Windows XP? If you are still using Windows XP, I feel really sorry for you that that's where you're stuck at. Like, computers have come down in price. That's all I can say. Save up your money, work hard, find some way to, you know, get your hands on a newer system. But anyway, back to what we were doing. Latest Python 3 release. Files. We're going to go with the Windows installer 64-bit. We're going to skip the embedded package, and we're just going to go with this. That's going to download. We're also going to download the help file. Because, why not? I mean, it's a help file. Worst it's going to do is help us or not do anything at all. I don't know. Now, if you're of the paranoid variety, there are hash values here that you can check against what was downloaded. I don't believe I've ever had a problem with that here on the website directly. I also have not installed my MD5 sum checker, so I won't be able to do that for you. I won't be able to show you how that all works. But anyway, go into downloads, or just click the file down here on the bar, and ta-da! We have launched the thing. If you have the option to add Python 3.10 to path, go ahead and click that. If you are administration for your computer, if you're the main user, which I imagine most of you probably will be, unless you're on a family PC that your permissions have been restricted, you may have to talk to whoever's in charge. But go with the install now. This will do basically everything for you. It'll set you up. Be sure to hit yes on the weird little pop-up there, asking if you really want to install this, if you trust the file, blah blah blah. We are done with Chrome for now, though. Now, it doesn't usually take very long to install, so this should be a quick process. Depending upon your connection speed, it might go faster, might go slower. I'm doing this in the middle of the day. There's nobody else home. Nobody's trying to stream Netflix or anything, so I imagine it's just going to be pretty quick. I mean, I'm streaming this to you guys, but that's pretty much all that's going on my network right now. Ta-da! If you get anything other than setup was successful, try again. You might have to restart your computer. You might have to go into the add and remove programs and remove a previous installation or the previous installation. But keep trying till you get here. I'm not going to go through and debug every possible scenario on what can go wrong because computers, a lot can go wrong. I'm going to assume for the vast majority of you, everything went okay. If you did hit some kind of error message, Google it. Find out what that error was. See if you can find somebody else who's experienced that error on a message board or a forum, and see what kind of solutions are offered there. You will be surprised to find there is a lot of useful information about this kind of stuff everywhere on the internet. And you don't even have to try to get clever to find good search results. Just type in exactly what happened into the Google, Python install, error, whatever, and you'll find answers. Anyway, if you're new to Python, you can check out the online tutorial. They have a link just right there in the successful message. And Python documentation is also handy. Nice handy little link to have. So we're going to go ahead and click on that. Of course, it's going to open it in Firefox, but just go ahead and add a bookmark to that. Alright, we'll be showing you how to come back to that later so you can see how to use this properly to get answers to the things that you want to know when you want to know them. Alright, so hooray, we've installed Python. Now what? Well, first let's confirm that it actually is on the path. Okay. Let's try Python 3. That's unusual. Doesn't seem to have added Python. Well, that's weird. Doesn't seem to have installed Python at all. If it did, not really sure where it put it. It's, because that's an older version of Python. That's the one that I removed. Okay, so here we go. It does have Python 10 is there. I'm not sure why it's not coming up from the command line, though. After all, I added it to the path, so it should. I'll have to sort that out, figure out what's going on with it. Maybe my antivirus blocked it. It does that sometimes. Just gonna wait for this to finish before we launch idle. There's a new Discord link in the credits that'll show up at the end of the video than what I was showing yesterday. I forgot to click the this link does not expire for the things. Okay, so it says repair was successful. I don't know if that means it changed anything or not. Still trying to open it through the Microsoft Store. I don't wanna open it through the Microsoft Store. So alright, does have a command line option here though. But that's giving me the Python 2 one that I installed previously, so we don't want that. Nope, that's still the wrong one. Python. Alright. There. This is what you're supposed to get when you type Python at the command line. It's supposed to spit out this junk, and then it's going to give you these three these three angles for a prompt. This is the interactive Python interpreter. Now you can just simply enter Python commands right here, and it'll give you immediate feedback. Just like that, which is all fine and dandy, but, you know, not super convenient for if you want to save a project and come back to it later. But this is how you would test, you know, various statements to see that they'll actually function if you just want to, you know, see if a statement is, you know, gonna give you some kind of error message or something, or syntax error. Now, the great part about Python is it's super user-friendly. I mean, for the most part, today it's decided to kind of, you know, be weird. Where did it install this? Okay. I should have done a custom install. And in fact, that's what I'm going to do right now. I mean, we'll still use this. We'll still get away with it. It'll be fine. But run that as administrator. Yes. Oh, it's going to have me modify and remove it. You know what? We'll just go ahead and uninstall that for now. Yeah, removing it from path. Well, you didn't do a very good job adding it to path, did ya? It usually goes smoother than this. It usually does. I've installed Python a great number of times. Usually don't have this kind of a problem. If you've gotten to the point where you've installed Python and you're able to launch it from your start menu, you don't have to uninstall it and do what I'm about to do. It's just, I'm nitpicky about how I like things. I don't want Python installed to a local users folder. I want it installed to the C drive, the programs folder, you know, where it can be simple to find and launched through anything. I want to be able to open the command line and type Python and have it, you know, give me the Python interpreter right then and there, you know. So I'm going to see if I can do that. Add to path. Documentation, install the documentation. Sure. Install pip, absolutely. Install idle, yes. Test suite and libraries. Hold on. Did I not do this as administrator? Run this as administrator. So I want to make sure that's not giving me any issues here. Okay. Install for all users. Associate Python requires PyLauncher. Create shortcuts. Absolutely. Add Python to environment variables. Yes. Precompile the standard library. Absolutely. We're not going to worry about... Well, you know what? Sure. Nah. We'll skip that for now. Anyway, customize install location. Here we go. That's where I want it to install. That's the proper place for me as a programmer. That's where I like to see it installed. For you casual users at home, if you're not looking at becoming a, die-hard Python user, wherever it installs is fine, just so long as you know how to launch it. And I know, it seems kind of nitpicky for something so stupid, but when you do things the way that I do things, as far as your development flow and stuff like that, you want to know exactly where your binaries are. You want to know what folders your programs are contained in, and what drive, because my computer has multiple options. I have an entire 4 terabyte hard drive just for games. I have a solid state drive for the operating system. I have a separate drive that's just user files. That's just my user files. I have it set up this way because, if there's a catastrophe, if my operating system craps out on me, I don't lose all of my personal files. I don't lose my entire gaming library. I just have to reinstall the operating system. Now, I don't expect everybody at home does all of that. But anyway. Sure. Okay. So this is basically just Python 3.10, standard help file. If you've never used a Windows help file, navigation on the left there. I really got to set this up so you can see the cursor, so y'all can see what I'm pointing at. And then in the big white box there on the right, you have where it gives you the information. Assuming it opens. I mean, we're assuming a lot of things, aren't we? Huh. Well, alright then. So that's not working for us, but that's okay. It's okay. It'll still be fine. Alright, so we're going to open up our command prompt. Let's see if Python is now... Hey, there we go. Python is now properly added to the path variable. I can just open up command prompt, type Python, and it launches. That's the kind of thing that I'm looking for. Now, if you're a casual user at home, it doesn't really matter if yours does that or not, just so long as you can. Helps if I can type. Just as long as you can find idle Python 3.10 64-bit in your start menu. Because that is going to be our development environment. not the command line, unless you're comfortable with the command line. If you are, good for you. If you're not, this is going to be a much more friendly option for you. This, just like our command line that we saw, will give you this stuff here, and then it'll give you the 3-bracket prompt. Also, be sure to note there are some very handy instructions here. You can just type help, and it'll put you into an interactive help. Help utility. You'll know you're in the help utility because it says help. You can use Python keywords and modules and get more information on those. If you're just in the help thing and you need an idea of what you're looking for here, there's all kinds of topics. Let me resize this. I've got the font set, so yours will look different, but I've got the font juiced up so it's easier to read for those of you watching at home. So, let's say you've heard all kinds of stuff about classes, but you have no idea what that is. Well, you can just type in the topic, and be sure to capitalize. It is case sensitive, I guess. And it'll give you some information. It might be very dry and wordy and written like a college professor wrote it, and super boring, but I'm hoping I will have left you with enough information after watching this series, maybe not this particular session, but this series, and you'll be able to figure out what all this stuff means and be able to understand it better. For now, just know it's there. It's there to help you if you need it. Just type quit and you can get back to the regular 3-bracket prompt. Now again, this is the interactive where the commands you type in, you'll get an immediate response back, which is great for testing individual statements, but not great for testing an entire program. Not great for coding an entire program, I should say. So, for that, go up to the file and hit New File. That'll pop up a second window. It says Untitled up in the corner. Try and bring this down so it fits my screen. You shouldn't have a problem on your screen because your font isn't set to something ridiculous. But anyway, this window is where we can save our code so that we can use it when we want to and not just have to come up with it on the fly every time we need it. So that's idle for you. We've got the interactive interpreter right here, and then we've got our window here which allows us to save stuff. Now, as far as where you should be saving your stuff, in your Documents folder, I would just create a new folder. Call it Python code or something like that, so that you know what it is, you know where it is, and you know that that's where you'll be saving stuff. Now, all Python code saves as text files. So just like this Notepad program that's on literally every Windows computer, saves text files, the Python interpreter saves your source code in the exact same kind of thing. It just puts a Python extension at the end, but it's literally just text files. So, go like that, save. Alright, and to show you that it's literally just a text file, nothing more, go find that. We're going to go to all files here, and there you can see our hello Python file is right there. Hit open, and look at that. The exact same text. Encoding UTF-8. Same thing. You could actually just use Notepad to write all of your Python code, and it would be fine. It would work absolutely fine. I mean, you wouldn't have the interactive Python shell that you could test your statements against. You wouldn't get this fancy color-codedness that you get with working within the idle editor. But Notepad is a legit way to write source code for any programming language. Pretty much every programming language I've ever worked with has been text files that I can write in Notepad. Just so long as I save it with the proper extension at the end, it'll open just fine. Oh, excuse me. It'll open just fine in whatever interpreter I'm using or compiler, and it'll be as though I used whatever fancy tools you see programmers use. So, don't get bogged down with what editor should I use, anything works. Even Notepad works. Find one you like. That's it. That's the only requirement there. For our purposes, we're going to stick with idle. I'm not going to drive you over to the, to the editor store and help you select a new editor software and have you, jump through hoops trying to get that installed and working and able to work with your Python installation. Don't worry about all that. Python comes with one. Feel free to use that until you're comfortable enough to install whatever you want. Alright, so that covers installing Python and starting idle. Now, if you're using QPython, congratulations, you have had everything basically handed to you on a silver platter, hopefully. If you open up the app, you'll see options for console, which is just like the interactive shell here. It even has an icon that's got the 3 brackets there, and when you tap on that, it comes up with, the same sort of gibberish where it's got, the version number, and then, some, you got the version number, you got some build information about the version of Python you're using. It's even got this line here, type help, copyright, credits, or license for more information. And then it's got the 3 angle brackets. The 3 angle brackets prompt to show you that you're in the interactive shell. If you exit out of that, it'll ask you if you want to continue running that in the background. Go ahead and say no. And then back on that home screen, next to the console option, you'll also have editor and programs and QPy. That's just a package installer. We'll get to that later. But if you pop open the editor on that, it will give you... where's my mouse? My mouse has disappeared on me. I mean, it disappeared on you guys a while ago, but it disappeared on me. Gives you very much a similar text editor to what we're working with here in Idle, where we can save our programs for later. And, you know, in the top right, you should have a folder icon, and then a document with a plus sign, or just a plus sign, depending upon what version of the app you're using. The plus sign, obviously, new file. The folder icon is to open a file you've been working on. Underneath the editor, there's kind of a little toolbar there. You know, left pointing bracket, right pointing arrow, the disk icon to save, magnifying glass to search your text file, a play button to run it. And yes, it will run on your phone. You can test all of the code that you'll see us doing here right on your phone. Same as we're doing it here on the computer. So, have no fear, you can follow along. Now, if, like me, you manage to get Python installed properly into the path file for your computer, you'll be able to do something like this. This works particularly well on Linux installations. You'll start your file with this, and basically what this is a command that tells the terminal what program to go looking for when running this. We're gonna skip that though for our examples in this session. Just wanted to show you that as something that, you know, if you're on Linux, if that's what you're using, you can do that, and you just, you know, you can just run the file as an executable and it'll work. Okay, so we have our editor all set up. Are we finally ready to learn some Python? Absolutely. First thing we're going to talk about. Variables. Variables are important in programming. Now, I have heard a lot of different analogies for explaining what variables are. If you've ever taken algebra, you might be familiar with the concept of a variable. If you failed algebra, the very word variable might send a cold shiver down your spine. I've even read various, you know, coding tutorials where some will say, "Oh, it's like a box." There's even one that says, "Oh no, it's like an octopus tentacle." Like, variables are labels. That's it. Just, they're a label. Think of it like a label, because that's what it is. It's a label. It's a label for some bit of data that you're going to be playing with. And the reason that you have a label on it is so that you, the person writing the code, can read it and remember, oh, I know what that is. You know, that's the data for a cat. Or, you know, that's the data for the type of car that we're driving. Or, you know, something that doesn't start with C. You know, it's a label. This is a label for this data here. The equal sign between them is just assigning the data to the label. We can change that. we can change what our here, let me open up the tutorial or the interactive shell here. We can change what our label is pointing to. We can change what data it's referring to, which is why it's called a variable. It varies in what it's, what it's referencing. So, here we have it assigned cat equals Fluffy. If we go print cat Fluffy. Don't worry, we'll talk more about print. You don't need to understand exactly what that means right now, other than it outputs whatever's between the brackets. Since we put our label in here without any quotes around it, it just put the data that our label referred to onto the screen for us. If we put quotes around it, it'll print literally what's between the quotes. And like I said, we'll see that plenty. We'll see that plenty. Don't worry about that right now. The focus right now is just this bit here. What is that? How do we use it? What does it do? So, we've already said cat equals Fluffy. Well, we can change it. It's a variable. Yeah, my webcam, that's not a webcam, that's just an avatar. Welcome to the chat, Fern of Sigma. Hope I'm not being too, pretentious with how simplified I'm trying to make this. We're just starting with our Python tutorial. We had a bit of fun trying to get started with installing things. Alright, so I'm hoping you all understand now what variables are. Variables can hold or can reference, point to all kinds of different stuff. Numbers. When you see something between quotes like this, in programming we call that a string. Basically, it's alphanumeric text values. I mean, you've probably seen this kind of nonsense in your math class. When doing graphs and stuff. And again, it's just variables. You're assigning them a value. Now, a lot of what you do in programming is going to be math. But don't worry, you don't have to know math. The computer knows math. Half the time when I'm looking to do a math problem and I need a calculator, I'll just pull up the Python interpreter on my phone, go into the interactive shell like this, and I'll just type in the math problem that I'm looking to do. And it gives me an answer. And all the math operations are pretty basic. They should seem fairly familiar to you. That's addition. Subtraction, obviously. One that might not seem obvious at first, but after you've seen it a few hundred times, it becomes pretty clear what it is. Multiplication. Division, though, can be a little bit weird. Programmers are used to whole numbers just being referred to as integers. That's a pretty common data type in like C and basically every other programming language. And when we do math with integers, we expect to get back an integer. In Python, you'll get back a float. You know, some of you are probably just like, what the hell's a float? Well, float means floating point decimal decimal number. Basically, you get the decimal point and the fraction of whatever after that. Well, even if there isn't one, you still get that. So it's not going to have a huge impact on anything we're gonna do here. It's you know, it's just something to note. When you're doing simple division, you're going to get not so simple answers. Now, I know in Python 2 you could do that, and then you'd get back. Yeah, so that still works. Basically, if you don't want there to be a decimal point, do the slash twice, and it'll do what's referred to as floor division, which basically it keeps it as an integer. But don't get too bogged down with that. We're not too concerned with how the math works, just that it does work. If you can figure out how to do math in your day-to-day life, you can figure out how to form the statements and then make Python do your math for you. If you need to change the order of operations, because you know we've all seen the Facebook thing where, you know, someone posts some ridiculous meme of like, you know, and they go, oh, what does this equal? And there's like 18 different answers people come up with because they don't know how the order of operations works. We can clear up like how all of that's going to work for us just by using parentheses. So if you want to add something together before you're multiplying it by whatever, put parentheses around it. This will be done first, then the stuff on the outside gets done. Keep it simple, make it readable, and that's basically the Python motto, essentially. So, you know, if you have any questions about how things work with math operators, I mean, that's pretty much what we're looking at right there. There are a couple of weird ones that you may not have seen outside of Python, like this might seem a bit weird to you. All this is exponentials. Whoops. I forgot to mention, blank spaces matter in Python. If you're used to other programming languages, a blank space usually doesn't matter. In Python, it does. So we're just going to try that again. We're going to remove the blank space before the first three. And there you go. So how did it get 27? Well, 3 times 3 times 3 is what that is. I mean, it's exponential math, is all that is. Now, let's say you want to return the remainder of division. We've already seen division. We've seen how to get rid of the random little decimals when doing division. But let's say we want to know what a remainder is. for something we're doing division on. This percentage sign is what they use for what they call modulo operations. And what that'll do is it'll take the first operand, if we're using the proper name for things, or the first number, and it'll divide it by the second number, and it'll spit out the remainder. What's left over when you can't divide by this number anymore. And it comes in handy for certain situations, but probably not something you're going to run into a whole heck of a lot, so don't worry too much about it. Now what about doing things like square roots and stuff like that? Well, we have something for that too. There are plenty of functions in Python. I'm probably going to have to look up how to do square root functions. I haven't done square root functions in Python in a million years. Ah, okay. Yes. As I suspected. Okay. SQRT. Did I do that wrong? Do I have to import the... Yeah, I bet I have to import it. Yes. Okay. Yes, that's... Some functions have to be imported. Basically, this is how you access libraries from other people. If someone else has written some code that's very useful, it can be turned into what's called a package. You can install that and then use it. Python comes with a lot of pre-built, very handy ones. One of them is just math. So now let's try that statement again. And don't worry, we'll talk more about how to do importing, how to even write your own Python packages for the functions and code that you find particularly helpful if you want to use it again in another program that you write, so you don't have to retype everything over and over and over again. You just, you can just do it. So anyway, I feel like we've beaten math to death here, so not to get hung up on any particular topic, let's move on. Because it's all well and good to have variables, know how to work with math and stuff, but the real thing with programs is interactivity with users, being able to allow someone who's using your program to set certain variables to, get an output that's different depending upon the situation or depending upon the problem that they're trying to solve. I mean, it's great if 2 + 2 outputs 4, but if they need, 9 + 38, and your program outputs 4, we've got a problem. So we need to be able to take input, generate output. In Python 3, we use the input statement. Now, between the brackets here, these brackets, by the way, just indicate we're working with a function. And this is where you put your input arguments for a function. So if you want to pass some information into a function, it just goes there. The input function has an argument that you can, or a parameter arguments, parameters, we're going to use that interchangeably for a bit. It'll probably annoy some people who are professional programmers, blah, blah, blah. One's, for something else and one's for some. For now, don't worry about the difference. For the parameter, we can input a prompt. And it'll just spit that out on the screen. And then it'll put the cursor immediately after that, and your user can type in whatever their input is. And this will take any input as a string. So basically like, an alphanumeric, line of text. And when we put it after our variable equals, that's assigning whatever that input is to that variable. So now, in our program, we can call that label, and we now have whatever our user inputted. Pretty simple. They don't make things terribly complicated here. Now, that covers our input-output. Here's our input. This is our output. Between the two, you can do any number of things with the stuff that you now have. So, if we wanted to write a very simple program that just adds 4 to whatever number the user inputs, why you would want to do such a thing, I don't know. This is a very basic example to just show you what you've learned so far. So, this, by the way, is called a command, or a comment. Programmers use comments to indicate to whoever's reading the source code what that bit of source code does. It's nothing like the comments on YouTube. They're actually helpful. So, what we're going to do is, just as an example, we give our variable a name. We're going to assign it whatever the user inputs at their keyboard by using the input function. We're going to give that a useful prompt so that our user knows what they're doing when that prompt comes up, because otherwise it'll just be a blinking cursor and they'll just, they'll think your program stalled. Give it something useful, give it something handy. Now, I kind of expected this was going to happen. You remember how I said the input takes in things as alphanumeric, what programs refer to as string? It's alphanumeric value. You can't do math with alphanumeric values in the same way that you can do math with integers and the floating decimal numbers that we saw earlier. So what we have to do is we have to change the value type, not the actual value, just the value type. And the way we do that is with another built-in function, int. We'll turn it into an integer. Float turns it into a floating point decimal number. So if you're expecting a number from your user at the keyboard, be sure to change the data type of the of the variable. Like I said, it's just a label though. By using one of these handy functions. See, now this should work. Ta-da! Now we've been doing this whole thing on the interactive shell, which isn't going to be super helpful for us if we wanted to use this later. So let's start a new one. We're gonna call this new file adds 4. But we're literally just going to use the exact same statements that we just typed in over here. So, now, as you saw here when we first used the input function, it doesn't automatically put a space between our prompt and the user's input, so it can kind of run things together. So what I like to do is I like to give some kind of punctuation and a space so that it is clear when the user starts typing where their input is and what part of that is prompt. And it just looks a lot better. You don't have to be so particular about your own code. This is just how I like to do it. As you can see here, as we enter in our statements, we're not getting immediate output like we did over here. And that's because this is all to be run later. This is all going to be saved and then executed when we feel like executing it. We don't have to have it run right this second. Now we're going to skip this line here because that was something the computer printed out for us. We're going to go with this one though. Although, if you remember, that gave us all of this garbage, which at first can seem pretty intimidating, but as a programmer, I could tell you, this is something you'll see a lot of. Error messages. They always happen. Every time you write something, you're gonna see error messages. Don't freak out. It's normal. Alright, most of the time it just means you typed something wrong and the computer doesn't quite understand what you meant. You're not gonna break anything. Error messages aren't going to mean that your computer's gonna explode or anything. They're just a part of life, you know? So if you see one, just don't panic. It's just the interpreter saying, hey, are you sure you meant that? Because you probably didn't mean that. Now we gotta put our int function around our number label, which is the input from our input function. That value hold, or that label, points to the value that the user put in, which was an alphanumeric string. Our integer function turns that into an actual number we can use in math. And that math continues in the print statement. So, there we go. We're done there. Hit save. Go to run module, and the action jumps back over here to our idle interactive shell. You'll see restarts, and it gives you the location of the file we're trying to run, and then you'll see the input, the prompt that you set up in your input function right there. blinking cursor after it just means, hey, it's waiting for you to enter something. And you can type in whatever you like, and then, when you hit enter, it'll take that information, apply that num label to it so that we can use it later, because we don't know what you're going to type in. That's why we're using a variable. And then it does the math, it prints it out to the screen so that we can see it, and ta-da! You've officially written your first interactive program. I know, really stupid and simple, but, you can see how this may have, useful applications. Especially if you can do this on your phone. And, you want to be able to calculate something super quick. Like, how much your order is at a restaurant with the tip. So basically this would be 100% of the bill plus 20% tip. And if you're not tipping 20%, there's something wrong with you. So let's run that. Okay, so, we went out to eat. Our order came to 23, well, we'll say $23. So, we should definitely leave $27.60 if we're tipping a fair amount. Ta-da! Tip calculator. Now again, if you wanted to be able to use dollar amounts with decimals and stuff, change that int function to a float function. Now we can go $45.68. Now, again, it's going to do its own variety of math, so you'll have to round the number yourself. But there you go. We've managed to create a tip calculator. And, oh hey, welcome to the stream. I'm probably going to butcher your name. Ofhedznar? I'm doing great. Hope you're enjoying whatever this is. Yeah, we're doing a real basic tutorial. Ah, thanks. I try. Alright, so we have seen how to install Python, how to get Python on your phone, how to start idle, how to use variables, math operations. We're still not quite done, though, with input-output. Alright? We'll come back to a variation of input-output later. Because, this is just how to do basically command line input-output. When we get to graphic user interfaces, we're going to start using, text boxes and stuff like that. How do you get good at code? Well, a lot of practice will get you there. This stream will get you, if you follow it, gets you basic, a basic level of skill. But to get really, really good at it, you're going to want to keep practicing that and study further, more advanced concepts and stuff. Lot of places where they teach you how to code, they're going to tell you that you're going to want to code daily. They're going to want to tell you to set aside some time to do it all the time. I don't. I don't. I don't code every single day, but I'm also not currently working as a programmer per se. I develop my own stuff for now. But I'm also working on about a bajillion other different projects. So, I'm not employed as a programmer. unless you consider self-employment, working for myself, making my own programs. But a lot of practice will get you there. You don't have to remember everything. You don't have to memorize. Well, that's something you have to figure out how to do, is how to link it all together. If you keep following along with this, I'm going to show, I'm going to show you some basic stuff, but then we're going to get down to here. We're going to get to here, and you're going to start to see how a lot of this stuff comes together. By the time we get here, you should be familiar enough with how all of this stuff works so that you can make programs that have a user interface and you're not just doing command line stuff anymore. I get what you're saying about the whole not really understanding how to link it all together. Once upon a time, I hit that wall myself when learning how to do this stuff. And it's one of those things where you may have heard of what's called the aha moment, where it just suddenly clicks, and for some reason, like, you just suddenly get it, and you can't understand how you didn't get it before, but, yeah, it happens to everybody. But don't depend on that happening, okay? If you're really stuck on how to get things to work together, watch how other coders do it. Like, see how they put it together. Keep following along with streams like mine where I show you how to code. There are other programmers on Twitch who are also doing this same thing. They're probably doing a much better job than I am. This is just kind of a first attempt to cobble something together so people who watch my stream can understand what it is I'm doing on the screen, and they can participate and follow along. If I get to big projects and stuff like that at some point after the tutorial, it's going to be something that you'll be able to contribute to and actually write code for yourself, after having followed along with this. I upload all of this to YouTube as well, so it will stick around forever. Not just the 60 days or whatever it's allowed on Twitch. Let's see here. Where was I here? Where's my mouse? Okay, there's my mouse. I really gotta turn that on so y'all can see where it's at on my screen, because y'all don't see any of that, which is really too bad. Alright, so where was I here? Okay. Input, output. We still gotta do file, input, output, but that's a little bit of a more complicated thing. And we'll get to that when we discuss functions and objects in more detail. So I'm just going to throw that in here. But I'm going to give you a little bit of taste of how that works. You know what? Let's just open a new one. Close our old one. No, we don't want to save that. Of course, my ads for file name is absolutely inaccurate now, because now it is a 20% tip calculator. But who cares? We'll come back to that. Alright, so you've seen a little bit about how built-in functions work. And you've also seen how to save your code so that you can find it later. Now what we're going to do is we're going to save other data so that our code can use it later. Now, in Python, we can work with file objects. There is a best practice for doing this, though, and that's to use the with statements along with our open function. Now, the first argument for our open function is going to be the file location. Now, I want our file location to be, in here. So I'm going to put that there so that we know where the darn file is going to be. But we also need to give our file a name. We'll stick with our kitty cat theme. And we're just going to make it a normal text file. Nothing unusual. Now, our open function does require a second argument. Our input here, it had one argument that was, it was optional. You could have a prompt, or you could just not have a prompt. You could have a print statement beforehand that would tell users what to type in at the blinking cursor. With the open function, though, you have to have the file address, which is this bit here, all the way up to the file name and extension. And then after that, you need to tell it what mode we're going to be working with the file in. There's a couple different options. Read means the file exists and is holding information for us, and we want to retrieve that information. Write means our program is going to come up with some information and we want to put it in this file for use later, probably to be accessed with a read option later. And then there's append, which means that the file may already contain data. We're going to just add more data to it without overwriting what's already there. The write mode that I mentioned earlier will completely overwrite all of the information that already existed. So there's a difference there. Read, we're retrieving it. Write, we're creating new data, overwriting whatever might already have been there. And append, which is just adding to the data that's already there. For our purposes, kittens doesn't exist. So we'll be fine to go with write. And for that, you just use a W. Now you might notice there's a difference here in the quotes I'm using. With the file name, I use double quotes because it's a fairly long string. It's got some spaces. It's got some funky symbols there. I can use the single quotes if I wanted to, but I usually just reserve the single quotes for when it's a single character. It's a carryover from other programming languages that I've worked with. So, with open, our two arguments as, and then we need a label for our file. I'm just going to go with the simple F. And that's all that is. That's a variable name. It's a very simple variable name. Probably not a great variable name. Now, following that, I'm doing the colons because this is going to be a code block. I haven't introduced code blocks as a concept yet, but in Python, spacing matters. And normally, Like, say we were working with with Java or something. Spacing wouldn't matter so much, but you would see a lot of, this kind of nonsense where, you know, yeah, strings in the character within the quote, they're just different forms of alphanumeric data. It's not something we need to get hung up on with this because this is, again, super basic. We're not going for enterprise developer level stuff. Just, giving you a skill you can use by, learning the basics, learning something simple. And like I said, that whole thing, that's a holdover from other programming languages, where the double quotes means, longer string with all kinds of different symbols and whatnot in it, and the single quotes just means character. It really wouldn't matter in Python if I change this to a double quote, and if I decided that this was going to be a single quote. Really wouldn't matter. However, what I should do is I should escape clause all of these so that it does know we are using slashes. One of the things with alphanumeric text is some of the characters have special meaning, like that backslash. That backslash, in some places, will tell you to, add a line break. /n means new line. We're not going to get hung up on that until we do some fancier formatting with our print statement, but that's something to keep in mind there. Alright, so code blocks as they work in Python, though. We're not using brackets. We're going to end our initial statement, the one that we're starting our little code block off with colons. And with usually has a code block with it. And basically what it's saying is, with this bit here, with this file assignment, the following codes in this code block should work. If this part here fails, if for some reason it can't find our kittens file, or we don't have write permissions and it's not able to assign that file to our f variable because, I don't know, for some reason we're not able to use f or something. I mean, come up with whatever ridiculous scenario there. But if this highlighted bit were to somehow fail, the following code block will just be ignored and passed over. Now, after you type in the colon and you hit enter, you'll notice it immediately indents. That's how we know we're working with a code block in Python. White space matters. The indent here, you'll see, is about 4 spaces. You can use 2 spaces if you want. Most of the time you're going to use 4, or most of the time I use 4 to indicate a code block. And a code block is really just code that goes together. And you'll get an idea of what I'm talking about as we discuss this and the next part, conditions, loops, functions. You'll start to get a real understanding of what a code block is. Alright, so we got a little bit of time left. I want to wrap up the file input-output. Yes, Python is easy. Welcome to the chat, Yazzer Games. Reason we're starting with Python is because it's easy. It's super easy to pick up. Pretty much any idiot can do it. Exhibit A, my dumb face. Okay, so using our function open and our arguments to open the kitten file to write as f. We want to write some stuff to this file. So we call our file object. That's the label that we assigned up here, and follow that with a dot. And then we're going to use one of the predefined functions that comes with file objects. And because we assigned a file object to our f variable label, it'll have access to all of these. So, right. What are we going to call our kitten? Should we call it, we'll call it Spaz. Why? I don't know. Just came to me. Just came to me. Now, like I said here, up here when I was doing the double slashes, slash is an escape character that usually denotes a special symbol that you can't just simply type on a keyboard and have it happen, because if we were to try to type a new line there, it would look like that. We don't want it to look like that because that's not a thing. That's not gonna write properly to our file. But if we do that, it should, hopefully. But we might want to do it like that. Maybe. Otherwise, this is also an option and valid. Our alphanumeric string and our new line character. Now, if we run this, let's first save it. File writer. How many forms of error do we just get? Hey, no errors. How about that? Expect errors when you run your code. Always expect errors. Doesn't matter how long you've been doing it. Doesn't matter if you're an old pro. Always expect errors. No, let's open a new window. Let's open a new window. There's our file. There's our kittens file. We open that. As you see, Spaz. And there is a new line. So we've just outputted to a file. I know it seems a little complicated, but that's basically how you do that. With this function, execute this code block. Now, if you followed along and you didn't catch any of that, rewatch it. Hopefully at some point it clicks with you. This is just the label that we're going to use for our file object. This is the assigning of the file object that this function spits out to that label. And this is the code block that'll run, assuming that that function works and that that file object was created. Now, you should always close your files when you're done with them. That'll take anything that might still be in the file read buffer and, flush that out. It frees up the resources that your computer is using to keep that file open. Alright, now we have figured out how to write to a file. How do we read from a file? Well, we're going to do another with statement. Do another open statement. And we're going to use that same file. This time we're going to change the mode to read. Doesn't matter what you label your file object as. You can use any label you want. Now, as you can see, again, code block, we've indented, because spacing does matter in Python. Now, there's a couple of functions you can use to read. The most convenient one that I find is read lines. It just reads the whole file. If you're not going to have a huge long file, or it's not going to be, you know, just ginormous, read lines is perfectly fine. It'll read the whole thing. You'll have access to it, you know, right within your program, the whole file. You don't have to worry about it. Otherwise, if you want to use each line... Where's my kitten file? Did I close the kitten file? No, I have the kitten file right there. Let's say we wanted each one of these to be like a row in an Excel spreadsheet. You know, where we had a first name, a last name, a serial number, a, you know, pay rate, blah, 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 all the way across. And then the next line was that same information, but for, you know, say a different kitten or whatever. You would use just read line, and you could go one by one, put it in a loop so that it loops through each one. You could process each record as you went. For our purposes, though, we're keeping it simple. We're just going to read the whole file at once. We're going to take all of that data. We're going to put it in our names label. And then we're going to close it. Alright, now I still have our first function where we open it in write mode to write to it. That will overwrite the previously written kitten file. But it's just going to write the same information, so it's going to be like nothing ever changed. So, let's run that. Oh. I suppose it would help if we actually had some kind of, you know, output to see what the heck happened with all of that, right? Alright, so we look down here and we were able to pull our kitten name. But what's with the brackets? What's with you know, it's in there. You can see Spaz, the kitten name. But what's all this extra stuff? Well, read lines returns that input as a list. So let's say we did a couple more writes. We'll do this. Just to make it cleaner. Alright, So there you can see we have a new entry for each one. Now I'm probably doing this wrong, which is why I'm getting the new line character at the end there. But as you can see in our text file, the new line character is there, but it doesn't show up in the text file. It's just an actual new line character. And that's fine. There are functions to remove those, and we'll discuss those later. But what are these brackets indicating to us? This is a list. If you've programmed in other languages, you might be familiar with arrays. You might be familiar with, well, I guess arrays is pretty much the best one. Now, what we could do with that, say we don't need all of these, we can select the one that we want by just putting some brackets behind our variable name, and then selecting the index of that name. So, like, say we want to deal with Tom. Let's say we want to change the name of Tom in our file to something else. The indexing with lists in Python doesn't start at 1. It starts at 0. That's going to be a strange concept, but if you're a programmer already, it's not something you haven't seen before. But counting starts at 0 in most programming languages. We're weird like that. So, Spaz is actually at index 0. Spike is at index 1. Tom, it is at index 2. George, the fourth name, is at index 3. I know, it's a little confusing, but you'll get used to it. So, we'll say name number 3. We'll go names. Whoop. Helps if I spell it right. Whoops. So then I go and I screwed it up by targeting the wrong one. Thankfully, though, I didn't write those changes back to the file. So let's try that again. Because we wanted to change Tom to Fluffy. So, as you can see here, Tom, without the special symbols at the end. It's just printing out the 1. Also without the brackets. Why? Because we're referencing that element directly. So it's just giving us what's stored there. We took that name, we changed it to Fluffy. Now please note, we have no new line character there. So if we were to write that to file, it would probably put Fluffy and George on the same line, and then when we came to read it next time, they would probably be the same entry. Since we don't want to make that mistake, let's go ahead and put a new line at the end there. And then we're going to see if we can append, actually. Because we haven't shown append mode yet. So let's do append mode, and then we'll call this good, because we're just about out of time today, and I feel like we've covered a lot. Terrible file name, I know. Write lines? Can we write lines? I can't remember if we can write lines. Oh, wait, I don't want... I want to use Chrome so you can see how it'll look on your computer when you all are using Chrome, because everyone uses Chrome these days. Helps if I can spell functions. And helps if I can spell Python. Did I mention I can't type for crap? Yeah, you shouldn't go look at code and then basically just copy someone else's thing. Though, technically, you can. I'm not going to say that that's actually, like, completely terrible from, you know, every kind of standpoint, because such things as public repositories exist. And yes, every programmer always types wrong. Every programmer I've ever known has been horrible at typing. It's kind of like, you know, what we do. We're terrible at it. But you don't want to copy other people's stuff. At least not, you know. That is not exactly what I'm looking for, is it? No, it's not. Let's try file write functions. You know what? I'm just going to do this the easy way. We're going to do... let's see here. What was I talking about? Oh, yeah. To get started writing your own program. To not be stuck with a blank page going, okay, how do I get started on this? There's a couple approaches you can take. One of them is you can decide what options you want your program to have first, and then just kind of write up like a menu that would be printed to your user to choose from. And then with each option on the menu, like, you just start with the first option, work out the code for how that would operate. Go to the second option, work out the code for how that would operate. After all, most menus are fairly simple. It's basically just a list of if statements. If input is this, go here, run this function. If input is this, run this function. If input is this, run this function. And then each of those functions would be the code block that handles that option. A lot of people I've learned how to do this from, they start off with thinking of your program in terms of input and output. You know, what do you want being put into your program? What do you want coming out of your program? And then break up the editor so that at the top you have a comment input, middle you have a comment processing, bottom of the editor you have a comment that says output. And then you just fill in those sections. You know, the input section. Put in your input statements to get the data from the user, or, you know, put in your file opening statements to pull the data from the files. That kind of thing. The processing is, you know, what gets done to that data before it gets spit back out at the user or gets rewritten to a file. And then the output statements is spitting that information out to the user or printing it to the file. there's a couple different ways you can break up how to do your program. And the first step to writing pretty much every program is to break it up into the steps you want to do it as. I'm a fan of the creating a menu approach and then just tackling each option. I have used the other approach though, where you do the input, processing, output. One thing I like to do, I'm just going to show you this real quick. Like I said, we're about to run out of time though, so I do want to come back to this. We're not quite done here, but I do want to show you. Here, we better save that. One thing I like to do when I'm starting a new file, when I'm starting a new program, is I do this. Now, this doesn't seem like a whole lot, but we have a whole bunch of blank space up here. This will be where I put my definitions for my functions that I'm going to be using. This is where I put my import statements for the code libraries that I'm going to be importing to use in my own program. And then down here, underneath this if name equals main, this is what I want the program to do if I'm just executing it by itself as its own thing. And the reason I do this is because a lot of the code that I write ends up being useful libraries for things that I'm going to end up using elsewhere. Like if I'm going to write a card game like blackjack or poker, I'm going to have a file that's going to have a bunch of definitions for, class objects like, the deck of cards, the individual cards themselves. How does the card come up with the value that it's assigned? That kind of thing. And then here, underneath this, I'm going to have a basic demonstration of how to use those functions. And then this file will end up being a library in a bigger program. By breaking it up into the smaller steps, you're handling problems individually. So you're never stuck on, the big, ominous monolith of how do I make the giant thing. What you're doing here is you're just focusing on the tiny, on the little, I need to figure out this piece. I need to figure out how to do this simple thing. Once I get this simple thing, that's a small part of the big thing that I'm trying to build later. And what you'll find is as you tackle these little individual parts, you're able to pull them all in together by using, import statements. You'll know where to call the functions because you've decided how those functions should be called. And you'll design them with an idea of how you want to use them later. The best way, though, to get started with any project at all, is to not even have anything open. Like, you shouldn't be at your computer when you're starting. Shouldn't be at the computer at all until you have an idea of what you want it to be. Break out some paper, break out a drawing app or something, and sketch what you want it to look like. In the margins of that, write out the functions of how your program's going to handle the data that your user is going to put into whatever it is you've designed. And then decide how you want to display the information that your app comes up with after it's processed the information that the user put in. It might be something as simple as just a thank you for entering your name. Well, you'd You'd still want to know how you want that to look. What do you want that to do? Once you have those concepts and ideas on paper so that you can see them, it just becomes a matter of making those things on the computer happen. And if you're not sure how to do that part, Google it. You know, if at that point someone's already figured out how to make a dialog box appear, it's okay to copy that code. That's fine. If someone's already written that, no need to reinvent the wheel. Graphic user interfaces are a library, pretty common, used by everybody. Nobody's rewriting how to do message boxes and stuff like that. We're just using stuff that's already been written. Making it work in your app so that it processes the data the way you want it to, that your users are doing. That's what makes your program your own. And by thinking about your app before you type anything, before you sit down at the editor, before you attempt to come up with, the entire, monolith of the project, by just having it fall out of your head, plan it out first. Just sit down at some paper and write down what you want it to do, what you want it to ask the user for, what you want it to do with that information, and how you want it to present it back when it's done. It'll help with the whole being stuck on the blank page from scratch, going, okay, now what do I do? Because if that's where you're starting, by looking at the blank page going, now what do I do? Like, you don't have a plan. you don't have an aim. And you can't expect to get anywhere without some kind of plan. So a lot of programming actually happens way before we get to this part, where we're sitting down at an editor doing something. But we got to wrap this up real quick. So I'm going to give you a sneak peek at how to do a for loop. So we have our variable, which is a list. Lists are very handy for doing for loops because they have an index that, goes up by 1 as you progress through it. And that's going to be super handy for our list because we can iterate. And Python does a really nice way of handling this. For items in, and we're just going to use the variable that we have there. That's our list. And what this means is that for each of the things in, we're going to go with item. For each of the things in our list, we're going to assign the label of item. And we're going to write it. Oh, don't forget. The first line that starts your code block. Don't forget to add that little colon at the end. So we've got this one that starts this whole code block. Within this code block, we have a second code block. This is what they refer to as nesting code blocks. You may have heard that on occasion around the forums and stuff. You nesting code. Well, this is a code block nested within a code block. And this is the actual line that does something. Now, what this will do is it'll loop through each of the entries in our names list. Names is just a label for that list of cat names we have. And it'll write them to the file. And actually, we're going to append it. So now, what should we expect when we reopen this file? We should expect our list to be twice as long. Most of the names will be the same. But the second time through the list, if we did everything right, I did that wrong. But if we did everything right, Tom will have his name changed to Fluffy. We want to read this time. Names 2. Now, do not forget to close your files when you're done with them. I mean, it's not the end of the world, but it's just good practice. Alright. Oh, we should probably do something with that after we read it. Like, I don't know. Show it. Show what it says to the people at home, to the user. Okay. File. Save that. Run the module. Okay. So, the output here, we have it open and write our first list. It reads all the names. We had it print out Tom, which is the name that we're going to be targeting. It ran through everything, so it's gonna print the names again. Here's all of our names after we changed Tom to Fluffy. Then we wrote them back to the file. Well, appended them to the end of the file. So all of the stuff we wrote there originally, Spaz, Spike, Tom, and George, Spaz, Spike, Tom, and George are there. And then we appended the new list, which changed Tom to Fluffy, Spaz, Spike, Fluffy, George. Ta-da! And then we opened it one more time, read the new entry, printed it, and that's how we got this second line here. So that's file input output in a very very simple, very basic manner. We'll be doing more of that. I'll show you actual legitimate uses for the file input output in later coding sessions. This is just to get you a real basic understanding of how to do this stuff, like from the start, plain and simple. Because one of the things I have always found the most frustrating is how long it takes to get to the good bits of coding, where you're using files to save data, where you're getting information that's useful and storing it and making real changes on your computer, because that's an actual file that's now saved on the computer. Like I can go open that up in my little text editor. Oop. And look at that. The change we even made there with Tom and Fluffy and the list being twice as long. All that's there. That's now an independent file we wrote and created using Python. How cool is that? We'll get to some more cool stuff. More interesting stuff. I don't think I need to keep this. No, I don't need to keep this. But anyway, thanks for following along for our first session. We're a little over our time here for what I wanted this to be, but that's fine. That's fine. We did well. We got through quite a bit of what we were hoping to do. So, when we pick this up, I will show you how to change the course of your program based on input from a user. With our if statements, we'll tackle loops in a bit more in depth. We'll also hopefully get to defining functions, little bits of code that we write ahead of time, and then we can use them over and over and over again whenever we need them. We'll come back to file input output. I'll show you how to use that usefully in your programs, not just making kitten name lists and having fun with that, but actually, like, saving user settings, being able to read that and change how your program operates based on what your user prefers. Things like that. We'll also look at import statements, so you can write code once and then refer to it again and again and again in future projects, and you don't have to keep writing the same bit of code every time you need to figure out the distance between 2 points in a Cartesian grid. Let me tell you, as a game developer, that's annoying. You want to be able to write that stuff one time, know where it's at, know where to pull it from, and just use it. I'm also hoping we'll get to documentation, basically how to keep yourself informed of what your code does, because nothing sucks more than writing a bit of code, coming back to it a month later, and having no idea what it does. We're going to tackle that issue. We're probably not going to get to graphic user interfaces in the next session, but we will be set up pretty good for handling that. Anyway, thanks for watching. Y'all have yourselves a wonderful day.